Welcome back to Pure Science Education. Today's video we will be looking at exploring the arrangement of electrons in atom and focusing on different elements and learn how to draw the structures and write the standard electronic configuration. Before we do that, it's very important that you know the following points. Protons have a positive charge, electrons have a negative charge. Atoms are neutral because they have the same number of electron and proton, which mean the positive charge and the negative charge here, they cancel out. The overall charge is 0. The protons are inside the nucleus and do not have very much to do with the reaction because it's the electron in the outer shell that take part, and the electrons are in the shell or in the orbit around the nucleus. So just have a look at that first. So if you look at the structure, this is a basic structure of an atom. You have got your electrons that are represented by the X's here. You then got the shell or orbital. In the middle you got the nucleus, which is made out of protons plus neutron. So these are the different parts of the atom that we're interested in for today. Let's look at some examples from the periodic table. So if you look at this example of a lithium, how many electrons does lithium has? The answer is 3. And if we will look at this periodic table, you notice that the number of protons are equal to the number of electrons. So if I have 3 electrons, I have also got 3 protons. You will notice that my number of neutrons here, represent the n equals 4, is not the same. The reason being because number of neutrons can be different because we have something called isotopes that can be formed, which I will talk about in another video. So if you look at here, we have got 2 shells, and this is shell 2, this is shell 1. Each of these shells represents an energy level. So in this case we have got 2 energy level because we have 2 different shells. Now we're looking at an example of a boron, and this time we have got 5 electrons, which also means I've got 5 protons, but I have 6 neutrons. Now let's look at a different example. This example is of sodium. You will notice this time I have got 3 shells, so 3, 2, 1, which means it's got 3 different energy levels. I have got 11 electrons, 11 protons and 12 neutrons. So as I said to you, the number of electron protons will be the same, which gives you equal to them, and the number of neutrons are different. Now you got to be really careful in terms of an exam scenario. This is focusing on GCSE chemistry. I will be doing a separate video on electronic configuration for the A-level students, which goes into much depth and changes the way we write electronic configuration. So the one thing I want you to focus on, if I'm looking at sodium here, I've got the 3 shells, and I've got the first shell I've got 2 electrons, in the next I've got 8 and then a 1. But if this was a sodium ion, which is Na plus, then I will only have 2 shells because I would have lost 1 electron. So be careful in an exam if it's an ion or if it's an atom. So how do we write this electronic configuration? So this is the example of carbon, which has got 6 electrons in total, 2 and 4. Shell 1 I got 2 and shell 2 you got 4. So let's look at the fundamental rule. In order to write electronic configuration, you have something called a bus setting rule. The rule is in shell 1 you can only have a maximum of 2 electrons. In shell 2 you can have maximum 8 electrons. Shell 3, you can have 8 electrons, and shell 4, you can have a maximum of 2 electrons. This is for GCSE, so this electronic configuration is from hydrogen to calcium. So the rule, this is an octet rule that only works up to here, and when you watch the A-level video, you will see we introduced a transition metal where this rule does not follow. So how does this bus rule work? So imagine you have got one seat, double seat in the bus. So let's draw 2, and here you will have 8 and another 8, and finally the 2. So the way the rule works is, if somebody sits on the bus and it's only one person, they fill in the first seat, and then if it's another person, they come and sit in the next seat, and the maximum is just 2 seats, so 2 electrons. In the next shell, in the next row, if you like, in your bus, in terms of sitting, you have got 8 seats. Now you only fill in 1 seat as you go. These here represent electrons. So if I only have 3 electrons, then I only need to use 3 seats. So I've got 2 in there and 1 here, so that's 3. In this case, I have got 2 electrons in the first shell, and I have 4 in the next shell. So my electronic configuration becomes 2 and 4. Even though I have got all these remaining seats in the bus, I don't use them because I don't need them. So let's look at another example. So this is sodium. Sodium has got 11 electrons, and if you look at the rule that I just showed you, it's got 2 electrons in the first shell, 8 in the next one, and then 1 in the last shell. This is a sodium atom and not an ion. So if it was an ion, it will have 2 and 8 electronic configuration. Let's look at a non-metal. This is fluorine atom, and fluorine has 17 electrons in total, but sorry, fluorine has 9 electrons, and the first shell you got 2, and the following you have got 7 electrons, just shown in the diagram. So the electronic configuration is 2 and 7. Magnesium has 12 electrons. So in the first shell it has got 2, the second has got 8, and the final has got 2. So that's how we write down the electronic configuration. And the final one, argon, which belongs to the noble gases, it's got full outer shell electronic configuration, has got 2AA, which means it's got 18 electrons. 2 plus 8 gives you 10, and another 8 gives you 18. I hope you found this video useful. Thank you.